guys, today I am going to explain you the chapter structure of atoms of chemistry. It is a class 11 chapter and mostly very important for JEE. Many questions from this chapter come from the Bohr's atomic model. So let's start. First of all, the chapter starts from atomic structure, and it starts from Indian and Greek philosophers from 400 BC. Actually, the Indian philosopher first formed atom, and it was named as Padarth, but then Greek philosophers uh, like gave it a Greek word name as atomio, and then they didn't have any patent that at that time. So uh, then Dalton came and he just secretly snapped up the idea. Also, he just patented it, that he just patented that atom is the smallest particle to be ever existed in this universe. So it's completely wrong, and this theory didn't explain the gaseous laws like the law of definite proportion, constant proportions, or conservation of mass. So he was just um, like with a wrong statement. Also, J.J. Thompson more deeply studied on this, and he did a experiment known as cathode rays. Cathode rays is an experiment where you just take a discharge tube, high voltage battery of more than or equal to 10,000 voltage. Then you use cathode and anode. Like cathode is the negative terminal and anode is the positive terminal. Um, Anode is the positive terminal, right? Then at cathode you take a metal strip, and anode is perforated. So here in my notes, as you can see here, I have made this diagram. Like you can see, this is a discharge tube, then it is a high voltage current, and somewhat like that. So equipments required for this were vacuum, high voltage current, discharge tube, cathode, anode, perforated anode actually, and ZNS coating at the back of anode, because ZNS coating is gives a green glow when electrons strike it. Like at that time they didn't know, but now I know that. Now we all know that when electron strikes on ZNS coating, and ZNS is also called as phosphorescent or fluorescent material. So then a green glow appears. So why was vacuum used? If there is a question like why is vacuum used, the only answer is that to disappear the gaseous atoms, and if there are gaseous atoms, there would be a something like collision or intersection, something mathematical term would describe it. Then why is it called as cathode rays experiment? Because cathode rays were emitted by the metal EM. So EM, and then EM plus EG makes cathode rays. That is why it is cathode rays, because E were emitted from metal, and the metal was placed at the cathode side. It was a negative terminal, and negative electrons were emitted by the metal. And when they strike the gaseous atoms, if there is vacuum, but creating ideal vacuum is very very difficult. So you have to when it will have a little gaseous atoms, and when the electron will, with very high voltage, when electron will strike it, it will break it into another electron, and a positive charge will be held out, which is further known as canal rays or the anode rays. That were discovered by E. Goldstein, but just let's stick to this. Okay, then yes, if there were any gaseous atoms, then it will be struck by high voltage current, and then it would break down. uh, so yes, if there was any X gaseous atom, it would be break down by the different electron, and it will be X plus with charge and plus E minus, meaning it just broke down into an electron. Okay, so yes, then comes the Millikan's Aldrich experiment, the second phase of the chapter. Points to remember in this experiment are the properties of cathode rays. So the first property is that uh, electron has a mass. Why does it have a mass? Because why does it have a mass? Because when you put a paddle in that discharge tube, and when electron strikes that paddle, the paddle starts to move, like not continuously but a little bit, and then a little bit, and then again strike a little bit again. So this is what was performed to actually check that if electron has mass or not. Then the second property is that these move from cathode to anode in a straight line. Why does this move in a straight line? If this question arises, but most of the time it will arise in class 11th chapters, like next 2-3 chapters will like be most important, and theory part will be lesser. In JEE, questions are more, numericals are more, but just for concept clearance, I'll tell you that like when object was put and the electron strike, it perfectly matched the shadow, and it created a shadow, and then it was proved that they travel in a straight line, like straight. Object was put, and then the shadow was emitted. So just like if it wasn't straight, then it was like waveform, but it isn't, and hence it was called rays, and it was called cathode rays. Then the third property is the electron is negatively charged, the most important. Because why is it negatively charged? When we just put take the discharge tube, when you put up a positive terminal over here and a negative terminal over here, the electron which strikes the perforated cathode and enters the zinc sulfide coating, it just moves upwards at the positive terminal, and the universal law, as you know, negative attracts positive. So negative will always attract positive, and they will have an attraction in between, and negative will repel, positive will repel. Then next property is these rays themselves are invisible, but the irregular behavior can be observed by help of some fluorescent coating with when hit. Yes, these rays are invisible in nature. So by nature, electrons are invisible, but when they strike the ZNS coating, ZNS means zinc sulfide coating of fluorescent or phosphorescent coating, they produce a green glow. Hence it just just projects to in our mind, and our perspective change that there is an particle that is smaller than an atom, and that exists, like it is very small. Nowadays electron microscopes have come, but at that time still the scientists found it, so it is very impressive. uh, let's stick to the chapter. Then Thompson found the specific charge, that is E upon m. M is the mass of electron, E is the charge of electron. So the charge isn't found in this experiment, but the but the E by m ratio, or a specific ratio of charge by mass, was found by Thompson. Like it was 1.76 into 10 raised to power 11 coulomb per kg. 1.76 into 10 raised to power 11 coulomb per kg. Guys, if you want these notes, I will make a Telegram channel soon where I will put up these notes. Then you can join it. The next property is The EYM value of cathode rays does not depend on the kind of electrode used and the nature of gas present. It doesn't depend on the nature of gas or electrode used. Any electrode can be used, any metal can be used, or any gas can be present over there. Hydrogen, helium, lithium, beryllium, boron, carbon, like anything, and any metal also. But in anode rays it's perfectly opposite. It depends on the nature, because protons are emitted by the lightest gas called hydrogen. Hydrogen is like H plus is a proton. Yes, H plus is a proton, so that is why it depends on the nature of gas. If it take as He plus, it isn't a proton, so that is why. So these were the properties, and this was the cathode ray experiment. The next video will be uploaded of Millikan's ultra experiment. With the next video will be uploaded. Next video will be uploaded with the content of Millikan's ultra experiment and anode rays. Thank you.